Back again, guys, and from where we left it, we had the board pretty much complete. All I had left were the components that were external to the board, so the potentiometers, the LED, and the two jack sockets. I also have the power connector, but I've not wired that in because what I'll do in this case is I will just power it from the battery connector at this point, and hopefully I don't need to put the battery connector in or the power connector in to switch it. So what I've been doing, basically I've added flying leads to all these components, and I've also, if I just turn the board over, I've added the two bodge wires that the diagram, hopefully that's not too bright, yes it is, let's turn that down a bit. Okay, so these two bodge wires here and here that the description has said. I've also copied the order from the pots. If I grab for example this one and look on the back, this says B20K, so that would be the volume pot, and I've copied the same wiring, basically 1, 2, 3, but I've copied the same colouring on the depth pot, again blue, green, grey, and with the speed control that only uses 2, as you see, instead of being blue, green, grey, it's just green, grey. Now this isn't how I would normally leave. If I bring it back up and see if I can get a focus in on that. What are you going to focus for me? No. I should say the words that Ave uses for that, shouldn't I? Normally I wouldn't leave these like this. I would actually put heat shrink sleeving over them and completely seal them. But because at this stage I haven't drilled the board, drilled the case, and decided exactly on the positioning, these wires may well be too long for where I plan to put them. So at this point I've just left everything as flying leads with no sort of insulation on anything. So what we can do at this point is we can get the rubbish out of the way, straighten that capacitor up, and now we just add these components in the same as you would with the resistors and capacitors and transistors. Now you can start whichever side you like. In fact, this is from the power connector. Power connector there, battery connector, power connector C. I might need to, I don't want to short them out because that would not be a good thing. That's normally a switch, I believe. Let's try it and see. So if we start with the input jack, now I'm going to work on the basis that input is this side, output is this side, because that's pretty much the way all standard pedals work. If I just quickly grab this Boss tuner, as you see, input, output, so the input sockets are usually on the right hand side and the outputs are on the left. This is my daughter's. She said it wasn't working, and all I did was make sure the battery was good by sticking it across my tongue and plugging it in, and it works fine. So that was another easy fix. But I'm sure you don't want to see me licking batteries. It's probably not the best way of showing how to do things. But there we go. So yeah, we're going to assume that this is the inside, this is the outside. And again, because I haven't put the ring cable on here, what I'm going to do is I am going to cut a small piece of wire and just show you. Let's get a different colour to the rest of them. So we'll use a bit of yellow. Again, the diagram shows, I'm going to revert back to the diagram. The diagram actually shows the slope, and if you actually look at these, I don't know how well it will focus in, but you've got a slope here So if you look at it from the top, you've got the slope, which is your shield, your ground connection. You have your tip, which is your main audio input section, and then this is actually what they call the ring. What it does is it connects between the side of the, let me get a connector from my leads. What it does is it actually connects from here, where you'd normally have, say, a stereo connector, to ground. So basically it shorts that pin to ground, acting like a switch. So when you put that into there, you actually get continuity then between this pin and ground, and it's usually used in effects pedals to switch the pedal on and off, so that if there is no guitar plugged into the pedal, and I say guitar, I mean any input plugged into the pedal, if there isn't an instrument plugged in, it actually switches the pedal off to save the battery. It's a common thing that I've seen plenty of people do when they're not playing their guitar. They leave everything plugged in and then wonder why their batteries go flat so often. Well, it's because you've left it plugged in. So the ideal thing to do is to take the plug out and your pedal box will be switched off, which is another reason why I prefer using power supplies, because you just unplug the power supply and as you say, Robert is your brother's brother. Yeah. Yeah, I think that is. Bob's your uncle. Yes, is your brother's brother. Yeah. So all I'm going to do to add this extra wire is the same as we've done with pretty much every other wire. I'm going to just take a small piece, slot it through, get my little pliers. I could have bent this beforehand, or I could bend it out afterwards, but yeah, just put a little J hook onto the end of it if I can grip the wire and hold it in frame. Trying to do things floating in the air is not the best way of doing things. There we go. And then just crimp it together like that, so that there's no way that wire's going to come off that socket. And just get the iron, clean the tip, and drop a blob of solder on it to seal it in place. So that would be the input jack, all ready to go. Slightly longer wires than the others, but because, as I say, I'm not putting these in any particular order, it's not critical for what we're doing here. So let's start with this input jack, and let's put the input jack wire, so there's a connection for the in tip, in out tip and ring. So out tip is here, in tip is here, which is the white one. So just poke that through, turn it over, solder. Where do we solder it there? I say, try not to put too much heat when you're soldering wires in, because otherwise the insulation will just creep up and you're more likely to introduce short circuits. So it's as easy as that. You put the wires in and away you go. Next wire, which will be the ring, is there a in ring connector there? Yes. And then there's the where's the in ground going to be? Ground shield, V1, D1, S3, in tip, out tip, in ring, LED, PWB, PWC. That would go to the power connector, so that's not actually connected on there. As I say, that acts as the switch, so I probably will have to include the power connector in this little temporary lash up. So what have I got? I've got a yellow wire there that just needs soldering in, so we'll just put a blob of solder on there. rather than have you watching me solder all this, no, in fact I'm going to do the next thing, which will be a pot. And again, if you follow the colour coding that I've done, or you make your own colour coding up, you'll see that you know, blue, green, grey, blue, green, grey, blue, green, grey. You can then say that number 1 is blue, number 2 is green, and number 3 is grey. So you don't have to keep looking back at what you've done at the opposite end of the cable, and it doesn't matter which way they appear, whether you have them twisted like I do for neatness, or whether you just have each wire loose, or you can start with a grey and then have the blue at the end, whichever. So if we start with this, the depth pot, which is a standard 1, 2, 3, so I'm going to put that over, and there's the solder sliding off the bench. So we have depth 3, which 3 we know is grey, so we need to put that one, goes in there. Now this is where you measure out your wiring to fit whatever. Depth 2 is your green, which would go there. So depth 1 needs to be a little bit looser, so if we just unwrap that like that, we should be able to go to D1, D2, D1, D2, and D3. So I'm going to unwrap that one from green and just splay the end wires out so that they're straighter. So that's a 2. So D1, I know my fingers are all getting in the way and you can't see what I'm doing, and see, this is where, when you do it with the box in mind, you actually wire these in first before you solder to the pots, and that way you can get all your wires exactly the right size at this end, and then trim them to the correct size at this end, rather than doing them this way, which I've done just to show you how you organise your wiring, basically. Once you get a bit more sort of experienced at doing these things, it's just a matter of making your own system up. You'll find that there are easy ways of doing anything. Now this would be a horrible job, come on, melt, if you only had the wire as supplied in the kit, with everything being black. You'd then have to trace each wire through as you did it. Where are we? D1. Yeah, so this is one of the things that it's one of the few times on these kit builds that I would suggest that you do have just access to a small stock of components or parts, or as I say, in this case it just has to be a selection of wire. It doesn't have to be anything more extreme than variations in wire. So that pot is now on, and because we followed the wiring colours, we know that the pot is the right way round and it will turn. So when we get to the testing stage, which I will show you, and I'm going to use my little oscilloscope for that, you'll be able to see what's going on and how it works. Let me turn those lights back on, because otherwise we're going to get some pretty low quality video. So yeah, so those 3 are in. All you do is you just trim off the ends, same as you do with any other component. You've noticed I've used, in this case, solid wire. That's just a preference of mine, because you can bend things to fit into a shape if you want, and it just keeps things in position. Obviously if you flex it too much it's going to break, but you can keep things in position. And if you flex it too much, it's going to break. But if you flex it too much, it's going to keep things in position. And it just keeps things in position. Obviously if you flex it too much it's going to break, but if you flex it too much it's going to break. But you know, for this sort of thing, I much prefer it, because once you lay it neatly round the box, it stays in position. So yeah, there we go. Let me do the rest of this off camera, and it's just a case of soldering in. LEDs, if this is your first video with me, you'll have heard me, or you won't have heard me say, but the long leg is usually positive. Not always, but most of the time. In this case, I've used green for the positive, because brown is the negative on both the sockets, because that's the piece of wire I had the longest of. Normally, again, I would sleeve these so that they don't short out, but because this is an open build as opposed to a production build, I've just left it like this at the moment. So here we go, let's put the LED in. It will tell us LED plus, so we want the green wire in there and the brown wire in there. Go on, LED, get in. That's the trouble when you wear glasses. I have to wear them to see things that I'm doing close up, but I can't actually see sort of anything at any distance while I'm wearing glasses, because my eyesight is slightly not bad. I say slightly not bad, it's basically, I can see things when I'm walking around, but if I've got my glasses on, I'll trip over my own feet, which is the source of many a moment of amusement for work colleagues and the like. So let me just check that those are in. Yeah, and we'll tap the solder on there. You've noticed that again, using the solid wire for the bodge wire on the back here has allowed me to bend it through the traces so that I can still solder here and here and here without burning that wire. It's just one of the advantages of solid wire, that it will stay, as I said before, in a position. So anyway, let me do the rest of the soldering, and then we can get on with the trying it out and testing it and showing you what it does. See you soon. Okay, here we are. I've gone through and completed the soldering and put everything together, and I thought I'd set the thing up ready for testing and to show that it works. What we've got, let me just make sure that you can see everything on the screen. Let's bring everything a little bit further in. Yep, there we go. You've got this orange cable here, which comes from a signal generator. The reason I've turned the lights down is so you can see the oscilloscope. You've got the power feeding in from here, which is 9 volts. It's coming from a power supply, but it could be a multi-adapter, it could be any of the guitar effects pedal supplies. Here you have the oscilloscope probe, which basically just feeds the front end of this, and on here you have a headphone jack. You know, this is the output jack, and I've just plugged a set of standard headphones in, and the reason for that is so that rather than trying to do multiple oscilloscopes and plugging things out and plugging things in, I thought it'd be easier to just let you hear what it does. The 3 controls, obviously the LED is showing you that the device is on. This is your depth control, and this is your speed control, and this is the volume control, and they're all self-explanatory really. You know, the speed of it is how fast the signal oscillates. The depth control is how much is clean signal and how much is sort of oscillating signal. It's like a blend control. And your volume is the gain of the box. You know, you can turn it right down so that it's only slightly audible, or you can turn it right up, depending on whether you want a clean or a dirty sound on your amplifier. So anyway, what I'll do is I'm going to put the headphones next to the, well, in fact, I'm going to switch it off, and I'm going to turn the input down. Now, it doesn't seem to be too good at amplifying the signal. It actually does attenuate the signal somewhat. It probably could do with a better output transistor. This I believe to be the output transistor, but I'm not completely sure at this stage. Until I write the circuit diagram out, I wouldn't like to say which one's, you know, first, second or third in the chain. So this is actually showing the pure sine wave coming in, and trust me, on my other oscilloscope it shows an absolutely clean pure sine wave coming in. And as you see, it's sitting steady along the centre line, so that you can basically see that it's nice and flat and smooth. If I then turn the pedal on, you now see that although the level's gone down, that line is wobbling up and down, and that's what effectively the pedal does. It wobbles the signal up and down, louder and quieter around that centre line. So I'm just turning the input to the signal generator up so you get a little bit more volume, and I'm going to put the headphones against the microphone so that you can actually hear what the effect's doing. So here we go. Let's put this against the speaker, or the headphones against the mic. Okay, and now I'm going to change the blend control, the depth control, and you'll actually hear it's gone clean. There is still a slight wobble there, but not as much. You're actually hearing more of the raw signal, and as I bring that back in, you're going to get more of the mixed signal. Now the speed is obviously one that changes the most of the parameters, so hopefully you can hear both me and the tone that's coming out. Volume is nice and straightforward. There you go, you turn it down, you turn it up, and it wobbles, and you know, you want to slow it down so that it's a gentle trem effect. There you go, you've got a very, very slow oscillation there. If you want it faster, just turn it back and you should be able to hear it go completely mad. So I think this has been a long enough project. Let me move that away from there just to make sure you can hear me and not the sound of that. Hopefully you've enjoyed this little project, and you can see that even these what seem to be more complicated projects are actually very, very straightforward. Yes, you need maybe a bit more test equipment if you're going to do it through the tried and trusted test equipment method. You've probably already got, if you're building a guitar effects pedal, you've probably got all the test equipment you need. You've got a guitar, you've got the input lead, and you've got an amplifier. Just plug it in. If it works, then you'll hear it work. If it doesn't work, then you take it apart and you look for your solder bridges and you look for your bad joints and your connectors, and you go over that and plug it in again. And if it doesn't work again, then you keep looking. But to be quite honest, a circuit like this should work first time. There should be no real issues. Just follow the instructions and away you go. Life's like that. Thanks very much for watching, and hopefully I'll get this edited and up online as quickly as possible, so that you'll have something new from me to watch. Thanks very much again, and if you do like it, tell me you like it. If you don't like it, tell me what I'm doing wrong, and if you really, really like it and want to see more, then please subscribe to the channel and see more videos like this. Maybe better ones, maybe worse ones, but there are quite a few on my channel. Thanks very much. Bye bye for now.